Today we are going to solve a system of equations. Both equations are now non-linear, so we're going to focus on two quadratics or two parabolas. Okay, so looking at these graphs of two parabolas, how many solutions does this first picture show us? It has two solutions. How do you know that? It's crossing over at two different spots. Yes. How about the one in the middle? There's just one solution this time because we're intersecting at just one spot. And then the last one, they're not touching each other at all, so this is going to be no solution. Okay, so those three outcomes are still there. That was with our two lines, we could have one, none, or infinite, right? Yesterday with lines and parabolas, we had 0, 1, or 2. Today with two parabolas, we have 0, 1, or 2. They could all have the possibility of infinite if it was the exact, or not yesterday. Today, infinite could be possible because it could be two parabolas that are the exact same. So if it's two of the same function, two lines, two parabolas, two cubics, infinite is possible if it's the exact same one. Okay, we got two different kinds, like a line and a parabola. That's never going to line up, so can't happen there. Okay, based on our previous knowledge, oh look, I just gave it away. Based on our previous knowledge of infinitely many solutions for a system of equations, how would that look like on a graph? It would be the same what? What's it called? Parabola. It would be the same parabola. What would it be true for the equations? Yeah, it would be the exact same equation. So again, this can only be true if the two functions are the same type of functions. Two lines, two parabolas, that kind of thing. So what we're going to do is we're going to see an example of substitution, elimination. We got some graphing on the back. We're going to see an example and we're going to discuss, and then we're going to close the notes with doing some on your own. Okay, so let's see a couple of them first. Okay. All right. Tavia began solving the system of equations. She has negative 35 equals 2x squared minus 16x minus y, and negative 11 equals 2x squared minus 8x minus y. She decided to do it algebraically with elimination. She has started the problem. We're going to help her finish the problem. So it looks like she took that bottom equation and multiplied it by negative 1. To make the bottom equation 11 equals negative 2x squared plus 8x plus y. So from here, just like with our two lines, we squished together what we got. So look right here. What is negative 35? This is positive. So what's negative 35 plus 11? Negative 35 plus 11 is negative 24. What is 2x squared minus 2x squared? 0, they cancel out, nice. What is negative 16x plus 8x? Negative 8x. And what is negative y plus y? 0. Those also cancel out. How nice. What should she do next? How? Yeah, divide by negative 8. And we have x is equal to 3. What does she do with that answer? Plugs it in. Does it matter where? Nope. Which one do you want to use? The bottom one? This one, right? This guy? All right. So all those x's are going to change to a 3. So we're going to say negative 11 equals 2 times 3 squared minus 8 times 3 minus y. Order of operations, we do exponent first. So that's going to be 2 times 9 minus 8 times 3 minus y. 2 times 9 is 18. Negative 8 and 3 is negative 24. What do you want to do now? Sure. What is 18 minus 24? negative 6. What you want to do? Add 6, okay. So we have negative 5 equals negative y. Are we done? Divide by negative 1, and we get y equals positive 5. So this is showing that it has how many solutions? How many solutions? Just one solution, and it's happening at the 0.35. Yes, Conan.
So when you plug it back in, why is it a negative 8 instead of positive?
What are you talking about?
For the, because at the bottom it's 11 equals negative 2x squared plus 8x plus y. So why is it negative when you plug it back in?
I'm using the original equation from up here. Yeah. Yeah, when you plug it back in, use one of the originals. Yeah, good question. So these parabolas are only crossing over each other at one point, which is at the 0.35. How can we always check ourselves? How can we verify? We can plug it back in, okay? So we can check negative 11, 2 times 3 squared minus 8 times 3, now minus 5. We already did that first half, right? We know it's negative 6. Add that 6 over. Negative 5 equals negative 5. We don't have to always do this by hand. We can. This just shows we can always plug them back in and check. We could do the same thing with the first equation. We could plug in x, use 3 for x, and use 5 for my y. Make sure that ends up being negative 35 equals negative 35. I didn't have to do all this either. See, I'm rushing. I could have just stopped right here. I did too much. Negative 6 minus 5, negative 11. Boom. I did too much. We could also plug it into the other guy. Making sure it works here. 3 squared minus 16 times 3 minus 5. To make sure we get negative 35 equals negative 35, and it does. Okay. Why do you think, when given these two equations, why did Tavia choose the elimination method? Based on the structure of the equations of the system. So look at what was originally given to her. Why do you think she went that route?
She could get rid of the x squared and the y and just have to.
Okay, so she noticed she could easily eliminate 2 of the terms, right? It was the x squared and the y. Because they were almost the same thing. All she had to do was multiply one piece by the negative 1, right? By multiplying by negative 1. So when it comes to doing elimination with quadratics, you have to be able to eliminate preferably 2 of them. That would be nice. You could eliminate just the y and be able to solve for your x. It is possible, but if you can eliminate 2 out of the 3, even better. If you can only eliminate one of the x's, that is not going to do you any good, because then you have an x and a y. You can't, that's not eliminating anything. You still have one of each left over. Okay, so you got to make sure you have just one variable left, just x or just y. We good? Okay. All right, Carlos, he was given y equals negative 1/2 x minus 2 squared plus 3, and y equals x squared minus 4x plus 1. Okay, he chose to use substitution. So here's Carlos's starting. He started it off. What did he do? Let's see. He made them equal to each other. Then he multiplied both sides by 2. Why would he do that? Yeah, I got rid of our negative 1/2. Okay, so you multiplied both sides by 2, because now negative 1/2 is just negative 1. What does the other side turn into?
2x squared minus 8x plus 2.
There you go, 2x squared minus 8x plus 2. What do you think? What do you want to do?
Wouldn't you FOIL out the x squared, the x minus 8?
You would. We're going to. I wouldn't do it yet. We are going to FOIL. But all that other junk that's there, I can move it out of my way first before I do that.
6 and then divide by
Yeah, let's subtract 6 and divide by negative 1, and then we can do the whole FOIL fun. Okay, so we're going to subtract 6 over to give me 2x squared minus 8x minus 4. Dividing everything by a negative means everything's going to change its sign. So x minus 2 squared now is negative 2x squared, positive 8x, and positive 4. And now we will have to FOIL. The reason why this one has all the fun is because one of the quadratics was written in like vertex form and the other was in standard form. So that's why we got some extra fun math to do on this one. So this becomes x minus 2 times x minus 2, which will give me x squared minus 4x and then plus 4. Yes?
Why did you distribute the number to the other side?
Because you're trying to get rid of it. We're moving things over. What's up?
That doesn't make sense.
Which one?
Assuming the negative to the other side.
I didn't. I divided the whole thing by negative 1. I divided everything by negative. I'm moving my negative out of the way before I FOIL. I divided all of this by negative 1. So 2x squared became negative 2x squared. Negative 8 became positive 8. Negative 4 became positive 4. I'm dividing negative 1 out of it. So don't think of it as distributing. Think of it as taking it out. Because I want to take it out of up front. All right, now let's move stuff and solve for x. We want x squared to stay positive, right? So let's move all of this to the other side. We're going to add 2x. We're going to subtract 8x. We're going to subtract 4 over here. Add 2x squared. Subtract 8x and subtract 4. What is x squared plus 2x squared? 3x squared. All right, what is negative 4x minus 8x? Negative 12x. What is 4 minus 4? Woohoo! Cancels. That makes this way nicer. So what is your greatest common factor? So take out 3x. All right, so when we factor out that 3x, we're left with what? X minus 4? So what? We have 2 x's. We're going to have 2 x values. We have x equals 0 right here. And this gives me x equals 4. Good. Bye, honey. So we have 2 x's. We got to plug them in and find my 2 y's. Again, go off of one of your originals. Which one do you want to use? The bottom one? Sounds great. All right, I'm going to change. Let's do green. Do you want to plug in 0 first or 4 first? 0. All right, so if we plug in 0, well, that's nice. What's your outcome going to be? 1. When x equals 0, y equals 1. Are we good? Do I need to show that? We're okay. 0 squared is 0. Minus 4 times 0 is 0. Plus 1, y equals 1. All right, so that's one of my points. 0, 1. The other one was that 4. Let's plug 4 in. I got some kind of running out of space. Here we go. 4 squared minus 4 times 4 plus 1. 4 squared is 16. Negative 4 times 4 is negative 16. So this gives me what? 1. So I plugged in 4 and I got out a 1. Again, to verify, we can plug them back in and make sure they work. You can do it on your calculator. You can do it in your head. These, I would just type it in, make sure it works out. You don't have to make this step last too long, but it's always nice to know. We've already used the bottom equation, right, for both of them. So you can put them into the top equation and make sure that they also work. They do. So what does that mean about our two parabolas? They're crossing over two different spots. You could graph these in your y equals and you could see that. Looking at my two original parabolas, I see the first one's opening down because of the negative. My second one is opening up. So they're going flip-flop, so that makes sense that they're crossing over somewhere. Not always true because it could be like this, right? So it's usually 2 or none when one's going up, one's going down. All right, why do you think Carlos may have chosen to solve this with substitution this time instead of elimination? Well, there is a y. They're both equal to y. No, which helps, right? They're not. We don't really have the capability of stacking our variables with the way my equations are given to me, right? So the structure of them, since they're already both equal to y, you can make equations equal to each other. So the other one before, it was nicely stacked. We were good to go. We could easily manipulate to cancel out two of our terms. Our second one, stacking was not really an option, but they're both equal to y, so I can make them equal to each other. Okay. All right, now we got eco. Eco had y equals 3x squared plus negative 12x plus 17. And y equals negative 0.25x squared plus 0.5 plus 1.75. All right, so a lot of Eco's work is shown. Okay, he got this far and stopped and said that this system had no solutions. How come? So he made them equal to each other. He got everything to one side. What he had wasn't factorable, so we had to use the quadratic formula. He got to the second step of the quadratic formula, stopped, and said no solution. How did he know? Go back to your Algebra 1 days. What helped us determine?
Would it be the square root?
Something about that square root. What? It ends up being a negative number. Yeah. If the next step here, what is that? It is 156.25 minus 198.25. You get negative 42 under the radical. Okay. So Eco realized it was going to be square root of negative 42, which means there is no real solution, because we're in Algebra 2, right? There is a solution. It's just not real. But for the sake of our systems, we're focusing on the real ones. Where can we actually see that they cross over? These two do not cross over. Okay, so look at your y equals positive 3x, that opens up. Over here, y equals negative 0.25, that opens down. So this is an example of up and down, but they're on different sides, different pieces of the graph. They're not going to cross over each other at all. One's up here, one's down there. Living their best life on their own. All right, we have 3 graphs. These are each representing what we just did, the last 3 problems. I want you and your friend, someone close by, label them. Which one of these belongs to Tavia? Which one belongs to Carlos? Which one belongs to Eco? Okay, so label each of them with the name, and then I want you to actually label the coordinates or the solutions on the graphs themselves. Okay, so which graph belongs to which problem we just did, and I want you to actually plot the points and show where the solution is. All right, the first graph belongs to who? Eco. How did you know that? There is no solution. There is no intersection between those 2 parabolas. Beautiful. How about the middle one? Who? Tavia. I don't know how to say her name. All right. What was the solution to her set? It was 3, 5. Do we agree that this point of intersection is showing the point 3 and 5? Yes. Which means my last one belongs to Carlos. He had 2 solutions. Where were they? 0, 1, and 4, 1. So which one is this one? 0, 1, and this guy is 4, 1. Good. All right. Ready to try some? Yes. So it says solve each system of equations algebraically. Does it say to use elimination or substitution? It doesn't tell you. You have choices. So you do it the way you want to do it. Okay? You have options. Do them how you want. Let's just do number 1 and number 2 and then stop right there. Okay? 1 and 2, stop. Okay, we'll start with number 1. You could do substitution or elimination. I would look at this and I would go the substitution route. That's what my brain tells me to do. Because really elimination, I could get rid of the middle x, but I don't think I could get rid of, I couldn't do 2 at the same time, or not easily. So I'm going to go substitution with this one. I'm going to make them equal to each other. So I'm going to do 1/2 x squared plus x minus 9/2. Make it equal to negative x squared minus 8x minus 18. What can we do to make life easier and not have to deal with adding and subtracting fractions? Multiply the entire function by 2. Everything. Everything is going to get multiplied by 2. Everything. Okay. 2 times 1/2 is just 1. So that becomes 1x squared. 2 times x is 2x. 2 times negative 9/2 is negative 9. My other side is negative 2x squared. 2 times negative 8 is negative 16. 2 times negative 18 is negative 36. Like that. What's up? Because that is the denominator of my fractions. And that's what would help us get rid of them. Good question. Now I'm going to move stuff so that way my x squared, my x, and my constant are all together and that my x squared stays positive. So I'm going to move everything from the right over to the left side. So I'm going to add 2x squared. I'm going to add 16x. I'm going to add 36 all over. There's my 2x squared. Here is my 16x. And here is my 36. This first one gives me 3x squared. My middle piece gives me 18x. And my last piece gives me, what is that, 27? You got lots of factoring methods under your belt. This one, before I do any kind of flip and slide or basic or any of that jazz, I can divide the whole thing by 3. Make life easy. Take 3 out to give us x squared plus 6x plus 9. So now it's basic factoring because my x squared has a 1. So what multiplies to give you 9 but adds to give you a 6? 3 and 3. Remember, only pieces with an x can give you a solution for x. So the 3 on the outside does nothing for me. It stretched my parabola, but in the essence of x-intercepts, doesn't matter. My two factors give me the same x value, which is going to be -3. We're going to take him and we're going to plug him into one of the original equations. How about you want to do the top one? So I'm going to plug it into y equals -3 squared minus 8 times -3 minus 18. -3 squared is 9. Still have the negative out front, so that becomes -9. This becomes +24, -18. -9 plus 24 gives me 15, and then 15 minus 18 gives us that y of -3. So x -3, y of -3. These two parabolas are crossing over at the point of -3, -3, excuse me. There you go. So number 1 was geared more towards a substitution type of setup. Ready for 2? Ready for number 2? All right. Did we do substitution or did we try elimination with that one? Substitution. Yeah? Okay. I am going to show you both. So if I multiply, let's see. If I multiply this bottom equation by -2, no, that's not what it is. Bless you. Or -1, really. I can get rid of my y's. Did anybody do elimination before I show it? Or did most of us do substitution? You did do elimination? Okay. I'll do substitution first because most of you did it that way. So equal to each other. Like that. Subtract the x squared, add 2x, add 6 all over here. Plus 2x plus 6. So this gives me 1x squared. This gives me a positive 1x. 3 plus 6, that gives me 9. Does anything multiply to give you 9 and add to give you 1? Nope. So what did you have to do with this one? Well, no, it just means it's not factorable. So what's the one thing you can do? That's not why it's no solution. I cannot factor this, but what can you always use to solve a quadratic equation? The quadratic formula. I know it's your favorite. You're welcome. X equals -b plus or minus the square root b squared minus 4ac all over 2a. And this is why it's going to be no solution, because under my square root, I get minus 36. I don't even have to know what that is to know it's going to be a negative something, right? So this is why we know it's going to be no solution. Whoop. There we go. This shows me why it's going to be no solution. So it was not because it was not factorable. It was because when you solve with quadratic formula, it ends up being a negative under our square root. All right, for time's sake, I'm going to stop. You have an assignment. Make sure you get it done. Tomorrow we will review, and Friday we will do our quiz.